Hello guys, it's the final page of the tech-free Sac, and we've got a function that we need to find the centre and radius of. Now how do we know it's a circle? Well, we know it's a circle because there's an x squared and there's a y squared. An x squared and a y squared, so that would indicate that it's a circle. To find the centre we need both of those as perfect squares. We need to complete the square. To do that, first of all, we'll group. So we'll start off with x squared minus 2x, put the x's together, and then we've got y squared and 4y, put the y's together, and I would, you can at this stage even take the 2 over to the other side, that's fine. Just get rid of those little lines there, don't need them. Okay, so that would be like the start of the setup for this. We're grouping them together, putting everything in the right place. We're going to make a perfect square here and here. So how do we make a perfect square? Well, we halve the number in front of the x, which in this case is -1, square it and add it on. Now, I'm going to remember straight away to add it on the other side, because I'm keeping everything balanced. I've also got, and that will now be a perfect square. I've also got y squared and 4y. How am I going to make a perfect square? I'm going to halve the number in front of the y there, which is 2, square it and add it on. And of course I'm going to do the same thing on the other side to keep everything balanced. And that will be a perfect square. This first perfect square is the x from that square and the -1 from that square, all squared. And the second perfect square is the y from the first square, the 2 from the second one, all squared. And on the other side we've got -2, we've got plus, -1 squared is 1, plus 4. So we have x minus 1 squared and y plus 2 squared equals 3. -2 plus 5. 3. The centre, we can now read from that form, is opposite to the sign of the bracket +1, opposite to the sign of the bracket -2, and the radius will equal the square root of that number, 3. That question was worth 3 marks. There would be 1 for the centre, 1 for the radius, and look, I think 1 for demonstrating that you have to complete the square. You might get the completing the square wrong, make some mistakes, but if you've at least got one of them right, or at least shown the technique, you'd probably get a mark. I think something like that is the 3 marks. On to the last question. Okay, here it is. Got a function. This is function notation. In one way, it's testing that you know function notation. This function has got the name f. F is the name of the function, such that R is the domain mapped onto R, which is what we call the codomain, and the function of x is equal to x squared plus 1. Can I draw x squared plus 1? I certainly can. It's an x squared graph moved up 1. I'm just going to move it up 1. You could simply draw that. And you could label that 1 because it's moved up 1, and you'd be done. If you wanted to, really great habit when you don't have second points is to say, well, let's make x 1, and what do we get? If x is 1, y would be 2. So there's a point, say, there at 1, 2. How did I do that? I just let x equal 1, or better still, I did function 1, and that's 1 squared plus 1, and that's 2, and I got that other point. 1, 2. You don't need that. By restricting the domain, now the domain of f is the reals, but we've got to restrict it so that the function is 1 to 1. Now 1 to 1 has to satisfy both the vertical line test, makes it a function, and the horizontal line test, which means as it is, if I drew a horizontal line through that parabola, I'd cut it twice, it's not 1 to 1. Got to satisfy both vertical and horizontal lines. So I'm going to cut it in half at the turning point. That's the best way. I'm going to give my functions different names. So that one function would be named g, such that R positive union 0, we could do that, is mapped onto R, where Gx equals x squared plus 1. Remember, they've got to have the same rule, so x squared plus 1. So essentially, we're just cutting that parabola in half like this. A second function we might call h. This time I'm going to give it r negative. I might just give it r negative, like that. Doesn't say I have to use, that works. R negative just includes doesn't include the 0, which I put on the first function. Hx equals x squared plus 1. That's the function. That's open circle there. So I've divided that original function into two functions with the same rule, but different domains. One was the positive reals, including naught. The other one was just the negative reals. There's a number of ways you could have done that. Your teacher will work out if you've shown it correctly. There's different names, those domains could have been different. In fact, as long as it's one-to-one, that works. This whole page is worth 4. This whole last question is worth 4 marks. 1 for that function, 1 for that function, 1 for the graph, and 1 for the y-intercept would be the 4 marks. And that's a lot of explanation. I'll leave that. Well done on the SAC. Hope the solutions have helped you. Good luck with your work in the future.